When you have an equation set up with a sign like this, you have an I equals 1, and the I in the equation would just be 1. And when you have 4, that means the I will go count up 4 times. So as shown here, the I is plugged in, and because it's 4 up here, you go 1, 2, 3, 4. But the numbers in the equation doesn't change. So for finding the sum, you take and solve each separate equation and pull it down. Then you add them all up, add again, and you get 18. That's how you solve.
Okay, this is the arithmetic sequence, and you have to, you have these numbers here, and you have to figure out how to get to each number, and it's addition 4, and then AN is the last term, you plug it in, A is the first term, you plug it in, and N is the amount of numbers there are, and you plug it in, and then you solve, and you get 24, and that's good, because it's the last one, so it's good. This is the geometric sequence. Again, you have your numbers, and you have to, but geometric's different because it's multiplication, and this is times 2 in between each number. And then you have your equation for geometric. And AN is the last term again, and A is the first term again, and N is the N's different. Oh, it's multiplication. Haha! They got us there. And then you solve, you get the last term, so you're good.
So an arithmetic series is different from an arithmetic sequence, because a series is addition and a sequence is just a list of numbers. So here we have the addition, and it's plus 4 each time, and so to find the sum we use this equation. Sn is the sum of the terms which we're trying to find, and it equals n, which is the number of terms. We have 6, and then a1 is the first term plus an, the last term, over 2. And if we plug all the numbers in, we end up with 84. So 84 is the sum of all these numbers. Geometric series. It is just like arithmetic series, except it's times 2 instead of addition, but we still have the addition signs in between each one instead of a list of numbers. So Sn, sum of all of the terms together, except when using multiplication, you use this equation. In this equation that you use for geometric series, a1 is the first term, and then you do parentheses 1 minus r, which is the number that goes up, so it'd be 2, and then n is the amount of terms, and we have 6 terms, and then you do the same thing on the bottom except without n, so you'd have 4, 1 minus 2, 6 over 1 minus 2, plug it in, and you get 525.
This is the pyramid scandal. It's used in a lot of businesses. So it works, you have 3 people starting off, and then those 3 people have to recruit a person. And then those people that these people recruited have to recruit 3 people. And it goes so on. And as the people get recruited, the person on top gets booted off. And that's how the pyramid scandal works. This table, going to help us figure this out. So, you start with 3, because there are 3 people, and the total is 3. These people got more people, so it becomes 9, and now your total is 12. And then those 12 people add people, so it's 27. The process goes on, it's a long process. Okay, so now we have to plug in all of our numbers to solve. So, you have Sn, and that equals 300. And then you have A1, which equals 3 because it's the starting number. And then you also plug in 3 for R, so you plug it in right there. And then you have to divide by 3 by both sides, and you get 200 million equals 1 minus 3R. And then you add 1 to both sides, so you get 200,000,001 equals 3n. And then you have to divide by 3, but you can't do this, so it has to become log 3, 200,000,001 equals n. And then you divide by log 3, and then you get 17.4, but you can't have a decimal, so you have to round to the nearest whole number, which is 17. So, 17 rounds.
So I was stacking apples the other day in Walmart, and I figured, hey, how many apples are there? But I was too lazy to count. So my professor in college told me about this equation. So there was 15 rows of apples, and if you just squared each row, you could put it into an equation. And there's 1,240 apples. But I was too lazy to actually count all the rows, so he told me about this equation. And since this is neither a geometric nor arithmetic, you have to use this equation to solve it, which is n parentheses n plus 1 parentheses 2n plus 1 over 6. And n stands for the number of terms. So when you plug it in, divide it all by 6, S15, the sum of all 15 equals 1,240 apples. We want to figure out what's good, you know, put in there for the interest and make some money. Moolah, moolah. So we start with $6,000, and there's a 7% interest rate. And so for every year, it goes up off of what it was based last year. And when you get the final, you add it up with the total that would have been just 6 times 4, or 6 times 3, and then this is your total money that you earned from interest, from 3 years of interest. And the equation to find out how much you would make, the total sum of 32 years, is this equation, the 1 minus the interest and 32 years over 1 minus the interest, 6,000 on the outside, and you would come up with however that much that is, because I'm upside down right now. And the sum down here, if we want to find out how much interest we made from the 32nd or from 31st to 32nd year, we just put in the same equation, but only with 31, and then we take whatever the sum was and plug it into minus this, and you get that. See? This is the equation you use to find how much interest gets added each year as the money sits in your bank account. And then for 8D, year 31 minus 32 because of the growing compound interest.